Let's see. What do we have left here? We have this state's done. This state's done. Oh, this state here, right? I need. What do I do on? And apologies, I'm going to go ahead and use this part of the board here because I want to save this. I can say I can get a lowercase b, a capital. Do capital B first because that one's easy. I get S goes to A, B dot, and I'm done. Right. Now I have a lowercase b. Lowercase b, that's just this rule here. So over here. B goes to B dot B, right? Now I've got a dot in front of lowercase b, so I have to add all the b rules. B goes to dot B, B. And these are different items because I've got the dot in a different place. And finally, B goes to.
Sorry, is that symbol over there? That's up to B on the very right there, right? That arrow that's going up? No, sorry. The one that's going.
Yes, you're right. That is a very poorly handwritten uppercase thing. There's a reason I use electronic notes whenever I can. We're almost done. Let's see. I've got, for this one here, I've got an uppercase B. B goes to B, B dot. And what do I do for a lowercase b here? So, now, I need to go ahead and number these states. I can number them. It doesn't matter how I number them. Number them arbitrarily. But I want this one that I started with to be my first state. After that, doesn't matter how I number it, any order at all. Let's see. I'll do a breadth first search. Again, doesn't matter the order. 1, 2, 3, 4, 5, 6, 7. Right? 1, 2, 3, 4, 5, 6, 7. Woo. So now I create my parts table. My parts table, what do we have here? I've got state 1, 2, 3, 4, 5, 6, 7, 8. And here I have, let's see, I have my symbols are easy, right? I just have lowercase a, lowercase b, dollar sign. Lowercase a, lowercase b, dollar sign. And my non-terminals are SAB. Make sense? The reason I have this funny double line here is these are shift rule. These are what I do for shift rules versus go rules here. So I only use these after I pop something off the top of the stack and push on a terminal. Then I use these ones here, and these ones here if I look at the input and deciding what to do. So this part of the table, if I look at the input and deciding what to do, and then this side of the table is like, okay, I've just done a reduction. I've just popped the right-hand side of somewhere on top of the stack and pushed the left-hand side on top of the stack. What do I do right after that? So that's why this double line here is a little bit different. So now let's take a look here. 1 and an S, we go to 2. That's easy. And an A, we go to 3. That one's easy. And a lowercase a, we shift into 4. Make sense? And why do you shift versus go? Well, remember, it says what it means here for a lowercase symbol is, I see that on my input. I'm shifting over to the bottom of my stack. What does this mean? This means that, I've just done a reduction, or I've just popped a bunch of stuff off. I push that non-terminal on, and when I push it on, where do I go when I push that back on? So that's why this is an S, and that's a G. I'm doing a shifting from my input onto my stack. And to go, I've just done a reduction. After reduction, I've got to go somewhere. Where do I go after a reduction? Make sense? What? Okay. 2. That's easy. Just the dollar sign and the dollar sign. Whenever we see a dollar sign, we're done. We can accept. As long as your rules in this format where you have S prime goes to S dollar sign appears nothing else, nowhere else, then as soon as you see a dollar sign, you know you're good. That's why I went ahead and rejiggered this rule, so S prime goes to S dollar sign, and then the rest of the value. In that case, as soon as you see a dollar sign, you're done. All right, so that's easy. State 3 gets more fun. State 3 and a B, we go to 5. That's not a problem. And on a lowercase b, we shift into 7. And now for the fun bit. We've got a dot at the end of the rule, right? We've got the right-hand side of some rule on the top of our stack. And so, remember, for LR0, as soon as we get the right-hand side of the rule on top of our stack, reduce immediately. Don't even look at the next symbol. Don't care what the next one is. The right-hand side of the rule is on top of the stack. Reduce right the heck now. Well, right here, I reduce by this rule. And so this is rule, let's see, I'll name this rule 0, 1, 2, 3, 4, 5. That's rule 5. So immediately, as soon as I get to state 3, I want to reduce by rule 5. Reduce by rule 5. Reduce by rule 5. Now we have a problem, right? Because I'm in state 3 and I see a B, do I shift or do I reduce? There's a conflict. This grammar is not LR0. Let's push on. Finish up the rest of the table and see if it can help us out. State 4. We're going to have the same problem again, I'm afraid. State 4, and we see, let's see, lowercase a, we want to shift to the 4, right? That's not a problem. In uppercase a, we go to 6. And, but we've got a dot at the end of a rule, right? We've got, it's an A on the top of the stack, got this row on top of the stack, so we want to immediately reduce by A goes to A dot. So, rule 4, we also want to reduce by, what is that? That's rule 3. Reduce by rule 3, reduce by rule 3, reduce by rule 3. And the reason I'm circling these ones is this distinction between I'm reducing by this rule as opposed to shifting into a state. So I distinguish rules and states. Usually make it. Does that make sense? That's what I probably really should have done.
Wait, is that
Oh,
dollar
same.
sign is 3 or 5?
These are the 5 for all of them.
Oh, shit.
Yeah. I feel let me make it more clear by making it less clear. Make sense? All right, so we're almost done. State 5. State 5 is an easy one. Just reduce for the end of a rule, right? We just reduce by rule 1. So reduce by rule 1, reduce by rule 1, reduce by rule 1. No matter what. State 6. Or state 6. That one, we get this is not the end of the rule. That one's easy too. That's reduced by rule 2. Reduce by rule 2, reduce by rule 2, reduce by rule 2. State 7, ooh, same problem, right? See a capital B, we go to 8, that's not a problem. If we see a lowercase b, we shift into 7 again, just like we did before. But now, we've got it down at the end of the rule, right? Got it at the end of the rule with the b dot, and so that's reduced by rule 5. Rule 8 is easy, b goes to bb, that's rule 4. Reduce by rule 4, reduce by rule 4, reduce by rule 4. we're done, we've got problems. You have shift reduced complex. This grammar is not LR0. But it might be SLR1. What's the difference between LR0 and SLR1?
Is it something to do with left factoring recursion? No.
No, that'd be LL. So that way solve this for LL. So if we had a similar problem for LL, so we left factor and move left recursion, that's what we're solving LL. That's the way you solve it for this one. So it's in the same ballpark, right? Because it's how you solve the solution for different parsing techniques. So remember, for what's the problem with LR0? It's yes.
You have like a right hand side rule that could get rid of the two different things.
Okay. The problem here is like here's our problem right here, right? We got a dot at the end of the rule, and as soon as we get a dot at the end of the rule, we reduce immediately. Make sense? So you see this A, we immediately reduce this lowercase a, this lowercase a to uppercase a, right? But we don't always want to do that, right? In fact, let's take a look at some inputs here. My input is A, B, $. I shift this lowercase a, right? And then if I reduce this lowercase a to an uppercase a, I can't deal with this other lowercase a here. So what I have to do is shift this lowercase a, then shift shift this lowercase a, reduce this lowercase a to an a. So we'll have a on top of the stack. Then shift this lowercase a, this a to an a, and go forward from there. Let's see, that was not at all clear. So let me go ahead and actually do this out. Okay. I need these rules, so I'll rewrite them, and I will erase them somewhere else. Okay, so rule 1, 0, S prime goes to $, 1, S goes to A, B, 2, A goes to A, 3, A goes to A, 4, B goes to B, B, and 5, B goes to
Backwards. You got your 4 backwards.
4 is to be lowercase b, uppercase b. Thank you very much.
There we go.
All right, so let's take a look at trying to go ahead and parse something. So if I have A, B, $, right? Make sense? Let's go ahead and try to use this parse table. We're going to have problems with our complex, but we'll get by it. So I start off, and I'm in state 1. I say, okay, state 1, I see an A. Well, that's easy. I always shift into state 4. That's easy. So I shift this A into state 4. So I've got my stack and my input. Remember, by stack and input concatenate together always forms a valid partial derivation. All right, and so now I'm in state 4. What happens if I reduce, right? If I reduction here, I've got a problem. Because if I reduce, what does it reduce? Right? I need to pop this A up top of the stack, push this uppercase A on top of the stack, right? So I have to pop this lowercase a up top of the stack, push on uppercase A, and go to state. After I pop off lowercase a, get here, push on the A, go to state 3. Now I have a problem. State 3, well, I'm not allowed to see a. Well, actually, I suppose at state 3, I could immediately reduce that. I do a B goes to epsilon, right? So I could pop off nothing, push on a B, but then I'd have a problem. State 7, I'm not allowed to see an A. Make sense? The problem is, here, this always has to be a valid partial derivation, right? My stack concatenated with my input has to be a valid partial derivation. And I can never have an A with lowercase a after it, right? How do I know I can never have an A with lowercase a immediately after it, some valid partial derivation? The follow set of A is B and dollar sign, which means that in the middle of any partial derivation, the only thing that I want to have after an A is a B
The B.
or a dollar sign. Make sense?
What is that?
So now I'm sunk, right? Because if I did that reduction, I popped out lowercase a, I pushed on uppercase a, I've got a lowercase a after it, I've got an A followed by a lowercase a. Ooh, that'll never work. Make sense? So what I wanted to have done, if instead, let me back up, rewind time a little bit, what would have worked is if I said I started with state 1, and I see an A, I shift to state 4, just like before. And now in state 4, if I see a lowercase a, if I shift to 4 again, and now, state 4, now I can go ahead and reduce by this rule. So pop off the A, push on uppercase A, pop off the A, push on an uppercase A, state 4 and an uppercase A, I go to state 6, and now state 6, I've got an A on top of the stack, so I pop the A off top of the stack, and I push on an A, and 1 and an A, I go to 3. Ah, Joe found my A's properly, right? Now I've got the next problem here, right? Oh, state 3. I see a B next. Do I shift or reduce? Which do I want to do and why? If I reduce, then I'm going to get A, B, and then a lowercase b I'm never going to be able to get rid of again. So think about it, if I reduce, then I'm trying to say, let's look at the way the parse tree I'd be created from that one. I'd have S goes to AB, S prime goes to S dollar sign. S goes to AB, dollar sign, right? From the first one, I had S goes to A, and this A goes to A. And this B here, if I have this B go to epsilon, I'm sunk, I can't get the lowercase b. What I need to do is have this B go to the B, and have that B go to epsilon. Then I can generate this B. Make sense? A little bit of forward, back here. Top down, bottom up. Another way to look at it is if I go ahead in this one here and I reduce by this rule, right? I pop nothing off, right? It says I pop off nothing, I push a B on top of the stack. I pop off nothing, I push a B on top of the stack. State 3 and a B, I go to 5. Now I'm sort of stuck, right? To state 5, oh, I could go ahead and reduce, I could, pop these off, pop the A, B off top of the stack. And push on a S, but then I'm in state 1, I'm in state 2, and I see a B and a dollar sign and I fail. Or I can stop this point and say, oh, I've got a partial derivation with a B, uppercase B, followed by a lowercase b. That's a problem, right? It's not possible to have a partial derivation as an uppercase b followed by a lowercase b because the only thing that can follow an uppercase b in a partial derivation is a dollar sign. Make sense? So anytime I do a reduction where I'm pushing a capital B on top of the stack, the very next symbol had better be something that can follow an uppercase B. Intuition kind of sort of makes sense. So, with that intuition, all we need to do here is go back to our reductions. And I pick on all my reductions. I'll say I'll only reduce if it makes sense to reduce to that point. So let's take a look at where all our reductions are. The first one is the state 3. I can reduce by this rule here, If I reduce by this rule here, I'm going to push a b on top of the stack, right? And I only want to do that if what? Sometimes I want to do it. If the next thing is a dollar sign. So in state 3, I reduce by rule 5 on a dollar sign. And that's it. What about state 4? I've got a dot at the end of a rule here. So I do this reduction, I'm going to pop this off the top of the stack, push an A on. So the very next thing in my input, it has to be something that could follow an A. And what can follow an A? B and dollar sign. So I reduce by rule 3, B and dollar sign. State 5. S goes to A, B. Well, I'm going to pop off that A and B and push an S on. The very next thing, it better be something that can follow an S dollar sign. So like this one, I reduce by rule 1 only on dollar sign. And note that this doesn't really help us particularly because we didn't have a conflict before. What we do is we do find out the problem sooner. We find the error sooner. If I did this reduction here, I'd find an error eventually later on. All right, state 6. I reduce by rule 2 if I see something can follow an A, which is B or a dollar sign. So reduce by rule 2, reduce by rule 2. State 7. I want to reduce by rule 5 if I see something can follow a B, which is a dollar sign. And state 8, the same thing. Reduce by rule 4. There is I. LR 0. SLR 1 prostate.
Can you explain really quick the R2s for 6?
Sure. So sticks. I am got a dot at the end of the rule, right?
Yeah.
So I'll do a reduction by this rule.
Mm-hmm.
And this is rule 2.
Mm-hmm.
So when do I want to reduce by rule 2? Well, remember, if I'm going to do this reduction, I'm going to pop these off top of the stack and push the A out. So I'm going to have my input, it's going to have an A on top of my stack. And the very next thing in my input has to be something that can follow an A. So I only want to do this reduction if the next symbol is something that can follow an A.
So it would be a lowercase a
And what can follow an A?
or b
Lowercase b and a dollar sign. So this goes here, and lowercase b and dollar sign. Oh, excellent. So we do the reduction. It depends on how big the right-hand side of the rule is. So when you pop off the right-hand side of the rule, you sort of pop those off the top of your stack, and you sort of go back to the way you came. So if the rule had 2 symbols in it, you go back 2 symbols. If the rule has 1 symbol, you go back 1 symbol. If the rule has no symbols, like an epsilon, you stay where you are. And so, for instance, here, let's do some examples, and then take a look. When you're actually implementing this, your stack will contain not only these symbols here, but also the rules the states you came from. So you start off in state 1, and let's look at, A, B, B, dollar. Right? That's where I put. So I start off in state 1. State 1 and A, what do? State 1 and A, I shift into state 4. So shifts always shift, 1 symbol, 1 new state. So I go into state 4, and I shift that A over. State 4 and an A, what do? I shift into state 4 again. So I'm staying in state 4, I shift that A over. Now I'm in state 4, and I see a B. I see state 4, and I see a B. I reduce by rule 3. So what's rule 3? Rule 3 is A goes to A. So I know it has to be a lowercase a on top of the stack, because you'd never have gotten here unless there's lowercase a on top of the stack. So there's a lowercase a on top of the stack. So I pop that 1 lowercase a off top of the stack. And now I'm going to push A, uppercase A. I'm reducing this rule. I pop this off, push this off. So I push an uppercase A on top of the stack. Okay. after I pop the 1 after I stop, I was to state 4, and that 4 and that A, I go to 6. Okay, and now 6. 6 and a B are reduced by rule 2. So what's rule 2? Rule 2 is A goes to lowercase a, uppercase a. There better be a lowercase a, uppercase a on top of the stack, otherwise I have something terribly wrong. Oh look, there is a lowercase a, uppercase a on top of the stack. There always will be. Otherwise we couldn't have gotten here. So I pop those two things off the top of my stack, lowercase a, uppercase a, which gets me back to state 1. I push an A on top of the stack and state 1 and an A. I go to state 3. Make sense? And then I get state 3 and a B.
Wait, sorry, why did you go to state 3 from going from uppercase A?
Because I pop the right hand side of the stack, before I back to state 1,
Yeah.
and then I push an A on top of the stack, and a 1 in state A, a 1 in state A, and 1 in state 3.
Oh.
So the idea is I push on an A, push on another A. Let's see. Pop off the A to get back here. Push a little. Let's say on. Right. Pop off the A. Let's see. Pop off the A. Push an A on. Pop off the A. Push an A on. I mean, it's a little easier to follow, just keeping track of this. This is the stack of everywhere I've been, right? So when you do a reduction, you pop the right hand side of the row up top of the stack. That tells you where you are. You know what non-term you're pushing on, and where you've ended up after popping off, and that non-term which you're pushing on tells you where to go. That's what the G moves. So 1 and an A, you go to stay upward.
Sorry, how do you get the 1 there to begin with?
We always start in state 1.
Okay.
That's just where we started. We started in state 1, nothing else. So let's have this slow. State 1, haven't seen anything yet. And then I sort of go forward from that. So that's my initial state.
Okay.
So I start off my initial state, not my state.
So essentially you're growing from 1 with various different state numbers and their respective tokens.
Yes.
I got that. Okay.
And let's see, let's finish this off, and then we'll be done, because we're almost at time. State 3 and a B. State 3 and a B, we shift into state 7. So we shift into state 7, B. State 7 and a B. We shift into state 7 again. State 7 and a $sign. Reduce row 5. So this is where it gets fun. We pop the right hand side of the roll off the top of my stack. Well, how many symbols on the right hand side of the roll of that particular roll? Good question. 0. So I pop 0 symbols off the top of that stack. I've now done that. And now I push the right hand side on top of the stack. What the right hand side of that roll is a B, so I push a capital B on top of the stack. And a 7 and a B, I go to 8. Now I'm in roll 8, and I better be doing some reductions. Yeah, roll 8. I'm at the end of the roll there. So 8, I reduced by roll 4. Roll 4 is pop off BB. So I pop off the BB. And now I'm in state 7 and a B, and I go to 8. State 8 and a $sign. I pop off the BB. So I pop off this B, and I push on a B. State 3 and a B. I go to state 5. State 5 and a $sign reduced by roll 1, so I pop off the AB. I push on an S. 1 and an S. I go to state 2. 2 and a $sign. I accept. So really, if you think about how this is being implemented, you have when you write like Bison or Yak, which do all this for you, just like JavaCC did all the principal process for you. the stack, it actually doesn't need to keep track of all these symbols on top of the stack because they're always the right thing, right? So what actually you need to keep track of is the state numbers. Because the stack is just the state numbers. For the rules, you don't have to store the rules. All you need to store is the length of the right hand side of the rule and the non-terminal you go to. Make sense? One final thing, and we're going to go. I'll probably keep you late here. What if you want to not just parse, say yes or no, you actually want to build a parse tree as well? So what you could do is, instead of pushing symbols here, you can push arbitrary data on top of the stack. So you do a reduction, you push arbitrary data on the top of the stack for that non-terminal. When we do a reduce, you can look at what arbitrary data you pushed on top of the stack before. And so you say, I do a reduction, I look at these symbols on top of the stack, I look at what arbitrary data I pushed on for each of those non-terminals, build a tree out of that, push that new tree on top of the stack. And so if you see something like Bison or Flex, you see $1, $2, $3. Oh, that's the first thing on top of the stack, the second thing on top of the stack, the third thing on top of the stack. Okay, that's just enough to do it later. So on Friday, we'll go ahead and we'll go over the formal